All right, thanks, Im. Thank you, Buckrell, for having me in the third version of LevelUp this year. So as Sam said, this talks about my API methodology and so what I call bad API makes happy hackers. So let's start off with myself. My name is Jasmine Landry, known as jr0ch17 on Twitter, Slack, GitHub, all that stuff. I'm a penetration tester based out of Montreal in Canada, and I've also been named a Bugcrowd ambassador last month. I'm currently ranked 53rd on Bugcrowd, and I also, since I'm from Canada, of course, I play hockey about 2 3 times a week. That keeps me sane of all this hacking and bug bounty that I do all week long. So the schedule for today, I'm going to talk a bit briefly about my methodology, the differences between black box testing and white box testing for APIs, um, information gathering, recon, which is pretty much generating error messages, and then technical bugs. So what I mean by technical bugs is bugs that can be detected by burp scanner. So like SQL injection, XSS, XSC, all that stuff, and then follow up with logical bugs. So IDORs, privilege escalation, information leaks, something that needs the brain to understand, and that burp won't detect since it doesn't have a brain. So a lot of people reached out to me on Twitter or even at work. They always ask, where do I start for testing APIs? I have a hard time answering that question because when I started, I didn't know either. So I just ended up creating my own methodology, which I start by doing recon, as I said earlier, and then from recon, from what I've gathered, as information, from there I can look for technical bugs. So RCE, SQL injection, all that stuff, and then I follow up with logical ones. Sometimes I start with logical ones if I see that the information that I see in the responses are different. Let's say there's a PII or PCI, then there's a good chance that if I find something with that, the payout will be a lot bigger and better. But I personally prefer looking for RCs, stuff like that, because it's just my preference. I just have more fun doing so. And it's important to follow step by step so that you don't forget to test anything. So the more you test, I guess the bigger your attack surface is, the more bugs you'll find. So let's start off with the black box testing. So for APIs, it's pretty much trying to identify as many endpoints as you can, either by going through all endpoints in the application to generate API calls. You can look for endpoints in GitHub. You can run brute force tools like jr0ch17, GoBuster, or other tools like that to identify other endpoints as well. And also, you can look in JavaScript. Sometimes you can see API endpoints in there as well. And also to test all available methods. So not just get and post, try, put, patch, delete, and so on if there are more available. Sometimes you think there's only a get and a post, but if you send a put, it'll behave differently. So yeah, you just never know. So I strongly suggest to test all of these methods when testing for APIs. And then for white box, if there is documentation, absolutely read it, try it out. Make sure you generate a working request for each endpoint. So that means you need to get a 200 OK for everything. If not, that means that you don't have a working request, so you don't know what the API is expecting. So you don't know what to test to find bugs. If you have a Postman collection, proxy it through Burp Suite so that you have an easier way of testing. I mean, you can also test in Postman itself, but if you want to automate stuff, I think it's better with Burp. This can be a long manual process, but at the end of the day, if you took the time to understand each API call and each endpoint, the easier for you it'll be to find bugs. So let's continue with information gathering or recon. Like I explained earlier, for APIs, if you don't have documentation, it's really tough to find bugs. So the goal is to generate error messages which will leak information like let's say a stack trace or something like that, so that they have an idea of what's used in the backend, so that it could be easier for you to find RCs or SQL injections if you have an idea of what's used. or technologies are used in the backend. So to do this, you can send multiple types of data. Let's say it's expecting a string. Go ahead and send an integer instead, or a Boolean value like a true or false or even null or an array. You really never know what you'll get in the response, and sometimes it's not expecting that, so it'll spit out a ton of information in the response. Or if it's expecting an integer, send a string and so forth and so on. Just make sure you test everything as much as you can, and you'll never know what you'll get. Again, try all available methods. Here I even put QWE as the first 3 characters on the keyboard. I had this case about a month ago. I sent this as the method, and it said like a regular response of 4 or 5, saying that method is not available. But after that, I had like a big stack trace about the framework that was used. So this was a good information gathering that I could that I used later on, since I knew like the full path and stuff like that. And also send malformed JSON. As you can see here, there's a second double quote after the value of the bug key. So after LevelUp 3, sometimes it's pretty rare, but it does happen that you'll get like a verbose error message here as well. You mostly get like a malformed JSON error, which is pretty basic and simple, except sometimes it happens that there is more information in there. And also, as you can see in the screenshot here, the API was expecting only alphanumeric characters, but by adding an ampersand at the end of the value that I put in, it simply gave me an API key that was used by a third party for that program. So this is a P1, which was pretty easy. There's also another way to fuzz and get error messages, which is not manual, but you can automate it in Burp. It's something that not a lot of people know about, I think. So let's say you have a request, you send it to intruder, and then you select all positions to scan. From there, you simply right-click and select scan define your insertion points. So this will only scan what you selected. It won't like try other methods. It won't test anything in the URL. It only scan what you wanted to do. And also, if you install the error message checks Burp extension, this goes along really well with this. You'll get scanner findings in your Burp dashboard about what error messages it found. So this is a nice way of automating as well. So like sometimes it's expecting only like 8 characters. If with Burp Scanner, it'll try more than 8 characters, and you'll get like a nice error message, which helps later on. So with technical bugs, I usually get either RCs which can be achieved with server-side template injection, file uploads. Most of the time, they are file uploads. Something like this, like you specify the file name and then the file content, which is basically for encoded. But most of the time, we can change the content type from image PNG to either application XML or text HTML to get an XSC or stored XSS. This is actually something that Shawn tweeted about not too long ago. I found it pretty funny that he tweeted this when I had already put this in my slide. So that's pretty cool. So yeah, we're 2 now that suggest doing this. And in this example here, it was a file upload of a Groovy script. So I simply put in this simple one line Groovy command that executes the sleep command on Linux, and indeed the response took 10 seconds to it took 10 seconds to respond back from the server. So this confirmed that the RC worked. It was blind, so I had a hard time getting information back, but at least I confirmed that there was an RC there. And again, to add on file uploads, this one is a bit different. The content type was in a separate key, and then the file name again a separate key, and the value was base64 encoded.
Oh, really?
This is simply my my XSC payload.
Yeah.
And then in the response, I got this error message of invalid XML,
Nice.
which pretty much told me what it was expecting wasn't there in the file.
The octopus one?
Pretty much in the file. And
Yeah,
then
my old
either I
laptop.
didn't have the response. I didn't have like the password file that I put in my payload in the response, but I was able to eventually figure it out out of ban and get the contents of the file on my server. So yeah, it happens pretty often now. Well, from what I see, that there are file uploads and APIs. So this is definitely an interesting way to get RCEs. This was a case of SQL injection. So some people think that there aren't SQL injections on APIs. That's not true. It actually interacts with databases quite often. This was a post request where it did a search within the database. So I simply put in a single quote after my name since it was only expecting, I guess, letters. And then in the response, I got a nice Oracle SQL error message, which pretty much said missing right parenthesis. So from there, I knew it was vulnerable, and I just sent it on SQL map, which did the job for me just to automate and make it easier and faster. So as we can see, I found in two databases. I got the user and yeah, so regular basic SQL injection here. And then from that one, I actually found another endpoint on that same API, which was also vulnerable. This one was blind though, so there wasn't really much in the response. So I looked up a bit of CVEs for Oracle databases, just by curiosity, and I found this one, which actually worked back in 2014. So this is like a 4-year-old CVE that existed on the production API. So it's pretty much an XXC within an SQL injection. As you can see here in my screenshot, I sent the user that was being used by the database to my server. And as we can see, I did get it. So this is an interesting way of another SQL injection on an API. So let's continue with logical bugs, or IDORs for more specifically for now. So I typically play with 3 different accounts. If I have 2 organizations, I use 1 account from 1 organization and 2 users from another one, just to test like within my same organization, and also cross org. So cross organization is always like a bigger impact. So it's nice to test, and usually bounties are better. So I suggest trying to view, modify, and delete other users. I mean, by modify, I mean like create, edit, regular stuff. Other users information, both, like I said, in the same organization and cross organization. Also, try to identify IDs through information leaks. Sometimes the IDs are like long UUIDs, which you can't really be brute forced and can't be guessed. So if you find some UUIDs like this, sometimes you can use those to get IDORs. And it's usually just by testing with 2 accounts, you already know the UUID, so it doesn't really count. But if you're able to leak some through another request or something, then that becomes interesting. And also use burp intruder. It's a great tool to enumerate IDs. I mean, if you just simply guess an account, let's say it's a 4-digit ID, and you let's say 1000, you test 1001, it might not work. But if you test 0000 to let's say 2000, then you might get something. So just make sure you test as much as you can, and not just like a simple guess. This is an example that I had not too long ago. We can see here that in red, I had an ID that was vulnerable. This was a 9-digit ID, so pretty easy to guess and to use with intruder. From there, I was able to see other users' personal information. I was able to see, of course, their account number, which was the ID that I was brute forcing, or using with the intruder. I was able to get their phone number, first name, last name, an email address, as well as all of their subscribers. Again, all of their phone number, first name, last name, email address. So this was a big leak that I found. So yeah, there's IDORs everywhere. Just make sure you test them as much as you can. Try to find as many endpoints as you can so that you can test for all IDORs as possible. So now with privileged escalation, it's pretty similar to what I just said, except I do it a bit differently. I use 4 separate accounts, 1 admin and 1 user per organization, if applicable, obviously. And also test cross organization again. So what I do is simply replace the admin's authorization token with one belonging to the regular low privileged user, and do the same cross org. Let's say with the user 1, I test if I can access admin 2's data. So that this is usually a big problem as well. And sometimes it's pretty rare, but it does happen. So obviously you'd have to check this as well. Try to access endpoints without any authorization token at all. And you can also use the burp extension authorize. This is probably something you already know about, but I just strongly recommend using it. It's a great tool to use for privilege escalation. This was an endpoint that I found in JavaScript. So as I said earlier, make sure you look for JavaScript. You never know what you'll find in there. Oftentimes you can find endpoints which are pretty interesting. So for this one, there wasn't any authorization header that was needed at all. So I simply created a request, and here the request was a get a specific token. And with that token, I had access to pretty much the whole backend on the admin side or internal side. So I had access to all of the data that users put in. So again, another P1, which was pretty easy just to look at, just reading at the JavaScript. And last but not least, sometimes if you find, like, let's say 3 or 4 IDORs, or let's say all P3s, but if you combine all of them together, you'll get a P1 and let's say triple or quadruple the bounty. So this was a case about a few months ago that I chained IDORs to achieve an account takeover. And at the same time, it leaks PII and sometimes PCI. So I had my first IDOR. This was again a 9-digit ID, which in the response revealed my victim's email address. This was a simple GET request. Then the second GET request, another IDOR, by using the victim's email address, I was able to get their profile's UUID. Again, another GET request. And then the third one was a put, where by using their UUID, which I got from my second IDOR, I was able to change their email address. So I was one step closer of getting an account takeover. And then once that was done, I had 3 options for the account takeover. So a text message to phone number, or either send email verification link or answer security questions. The text message one was a bit hard, so I kind of skipped that one. The email verification link was a bit too easy and boring, even though it worked. I just, like, it was too easy, so I just figured out I'll use it, but I'll go a bit further. So I tried to answer the security questions. And so this was a post, and here we can see I simply used Postman for this one. There was a post to update the security question, so I simply updated it, put anything as the answers, and it wasn't verifying the previous answers of the question, so this was pretty bad on their side. And also we can see here that it required the ID that I got from the first IDOR. So from there I was able to answer the questions and reset the password and take over anybody's account. So yeah, so make sure to test as much as you can for APIs. Test all endpoints as possible, fuzz all keys and values. You never know what you'll get in response. Try to automate it with Intruder as well. Make sure you look up GitHub. Like I said, JavaScript as well. Sometimes Google Docs too works. And yeah, so if you have any questions, I'm available. I have my DMs open on Twitter and on some Slacks as well. So thank you for listening.
Awesome. Thanks, Jasmine. So yeah, looks like we'll take, we've got some time to take questions.
Sure.
Let's see if any have come in via, looks like nothing on Twitch yet, but if you do have a question, anyone, feel free to throw them in the Twitch chat or on Twitter. So we got 2 questions here. Firstly, are you going to share the presentation slides?
Yeah, I can do that for sure. Yeah.
Cool. So yeah, look for Jasmine's Twitter. He can tweet out those slides at some point. We got a question about, have you ever found any race conditions by testing APIs?
I haven't, because I simply always forget to test it. I should add it in my methodology, actually. Yeah, but it probably exists quite often, but it's something I don't really like testing, to be honest. So I don't really test it, but it's definitely something that you should test.
Nice. Let's see. Nitesh Kumar asked, "Do you have any books that you suggest people check out on this topic?"
Good question. I'm not sure if there are. I don't think I've ever read a book on API hacking. Just everything that I've learned on that is pretty much with experience, just by jumping in it and testing and trying as much stuff as I can. But I can look it up, of course, if but I've never seen one, to be honest.
Nice. Nice. Our next presenter, Richard Rushing, just asked in the Twitch chat, do you find more bugs on servers or middleware APIs?
Most of the time it's middleware. It's pretty, I mean, it happens on servers, but most of the time it's on the middleware.
Alrighty. Cool. So we can hang out. Let's see. I'll check Twitter as well to see if we've got anything coming in. And by the way, everyone, we've got a couple more talks to go for the rest of the day. The next one is SecRich, or Richard Rushing. He's going to talk through his hacking toolkits and methodologies. So it's an afternoon of hacking methodologies. All right. Let me look up to see if we've got any tweets for you, Jasmine.
Sure.
Doesn't look like we do. So yeah, thanks so much, Jasmine, for everything today. We really appreciate your time and sharing this presentation with everyone. Like I said earlier, BugCrowd is in search of API hackers. We have some really interesting, challenging programs or challenging engagements that pop up with regards to API hacking and API testing. So please do, if you have that skill, please go to bit.ly/invites, please. That's invites PLZ, and that'll help you get some invites into some API hacking engagements at BugCrowd. So anyways, thanks so much, Jasmine. I really appreciate your time, and I hope you have a good day, man.
Thanks a lot, guys.